How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we are going to walk through standing up Nexus 50 and 51 and switch 12, specifically 50 and 51, in a VPC or a virtual port channel. Now, this technically goes outside of the scope for enterprise. So Nexus is primarily, like I mentioned in previous videos, a data center class switch. So it's normally going to be used in the data center to connect to your ESXi servers, not just ESXi. Basically, anything that's in your data center, you can use a Nexus switch to provide connectivity for. So, well, one of the key capabilities that it does is VPC, or virtual port channel. So we talked a little bit about chassis aggregation, but I wanted to take a couple minutes and just kind of go over what that actually means, because it can be a misnomer. So I'm going to pull over here and we're going to go to Google and we're going to look up at network chassis aggregation. What exactly does that mean? So images wise is some of these are an aggregation switch. So aggregation can mean you have two or more line cards that are plugged in together. This is an HP switch. So when we talk about chassis aggregation, what I'm referring to here, it would be like Cisco Stackwise, where actually it's just Stackwise. And essentially what this is going to do is it makes two physical devices appear as one. So here we have, this would be another version of Stackwise. This is on the Catalyst line of switches, and if I was to come down here, the concept is Stackwise virtual physical, where you've got a virtual connection between the two, the virtual link. So this is chassis aggregation, where you've got two physical pieces of equipment, but it's acting as one. So, and then what they refer to as a multi-chassis ether channel. You're connecting this device to this device and this device. You're doing a port channel on these interfaces right here. Even though it says PAGP, no one really uses PAGP. So that's essentially how that comes into play. And I'm not sure exactly what they've all got going on here. This is actually more of a deep dive into Stackwise Virtual. But if I was to look at Stackwise Virtual, yeah, it's basically the same thing, right? We have and this one right here, that's actually the one I was looking for. Let me scoot through this real quick. This right here. So Stackwise Virtual is when you have two chassis-based catalyst switches doing the exact same thing. Stackwise Virtual, with this says quad supervisor engines, and you got your route processor in there. Well, you end up getting duplicate address detection is the DAD, or at least it should be. I don't see the DAD term as I'm reading through this, but not terribly important. What you end up getting is you have this SVL, this virtual switch, Stackwise Virtual Link. It connects your, you connect your supervisor engines to it, Stackwise A to Stackwise S. You connect these two together, and then what ends up happening, you exchange information between the two. So SSO is stateful switchover. So this is essentially what we're trying to accomplish, is this. But Nexus calls it virtual port channel, doing the exact same thing with one major difference. With this type of design, and then with doing Stackwise, like with this, when you got Stackwise and you're taking the stacking cable, so we go back here to Stackwise cable, where when you're looking up a Stackwise cable, that's a quad, that's a breakout switch, or breakout cable. When you're looking at this cable right here is what is referred to as a stack cable. So literally it connects the back of the switches together, and it extends the backplane. So again, you've got, so each hand is representative of a switch. So you connect the two together with the stacking cable. It's a 1 meter cable, and that's what joins. If you click right here, this one here is actually a really good picture of it. Oh, thank you. Click on that. Really, I can't zoom in? That is super awesome. Thanks for not letting me zoom in. So so the left side here is the stacking cable. Let me go ahead and get out of the way. This is the stacking cable right here. You get this one plugs into this port. This one here plugs into the next switch down. Then this one plugs into the next switch down. And then the first cable wires up to the bottom switch. First port plugs into this first switch, second port, and they daisy chain together. You also have power stack. So this guy here plugs into this guy, so on and so forth. So if one switch loses power through its power supply, the other switches in the stack will be able to provide power to the other switch. So it's stacking power as well. With all that being said, the key difference between how this works with Nexus versus how it works in Catalyst is with Catalyst, all of the control plane appears to be one box. With Nexus, you are doing chassis aggregation, but each switch is managed independently. So your control plane is broken up. So you're communicating with each other. You've got the concept. There's two things you have to keep in the back of your mind and understand, or two terms specifically. You have the vPC peer keep alive, which is E11 is what we're going to be using for that. And that's basically just a ping back and forth between your devices saying, hey, are you there? Hey, are you there? And then you've got E12 and E13, which we're going to use as our vPC peer link. The peer link is what's going to allow traffic that comes in from switch 12 to hit 50 right across the peer link and then go out over here in the event that like the uplink for 50 to 41 goes down. You need a data plane connection between the two, and that's also what allows the switches to exchange information with each other, like synchronize their MAC address tables, things like that. So that's essentially what we're going to be doing. I'm going to stand this up for you. We're going to be doing the layer 2 connecting here, and then we'll get switch 12. We'll be able to talk to these guys via a port channel. So we're going to go through that process right now. I'm going to stand this up for you. I'm going to go ahead and get out of the way. We're going to start on 50. We're going to log into this guy, admin, and then admin. And there's a couple of, in order to do anything on Nexus, well, the majority of things, there's some things you can do on it without having to worry about it. You can create a VLAN, you can create a trunk, things like that. You can create a static port channel. But if you want to do anything beyond that, anything beyond very, very basic layer 2 networking, you need to turn on the feature. So the feature, there's a bunch of them. Right, the first one we're going to do is vPC. And then the next one is going to be feature LACP. Now, when we get to the point where we can do a SBI for VLAN 20, then we're going to have to use the feature interface VLAN. So now that we've got that in play, I'm going to do the exact same thing on 51. Come over here, feature VPC, feature LACP, and feature interface VLAN. So before I start doing any configuration on Nexus, the very first thing I like to do is a show run pipe include feature. What features have I turned on? Because I don't want to start trying to configure BGP, EIGRP, whatever else, unless I've got the feature turned on. So now that I've got both devices have the feature turned on, the next thing I have to go do is configure E11 to talk to each other. So the peer keep alive typically is going to be tied to the management VRF. So the management interface is going to have its own dedicated VRF, a virtual routing and forwarding table specifically for management. So you can manage the device out of band. And so what out of band means is, let's say I have a switch that I'm using for management. Well, that goes over here to some sort of cloud that is for management. It's supposed to be in M. Well, what I would do is I would take a port out of this guy and I plug it into this guy. I take a port out of this guy and plug it into him. Both of those ports are plugged into the management port of both switches. This would be referred to as out-of-band management because I am not using the in-band network, the network that data users would be traveling through. I'm going to be using another connection somewhere else in order to connect into the switch in order to manage it. So normally that's what you would use. So in this case here I'm using E11 on both switches in order to do that. Because I'm doing that, I have to go create a VRF on both switches and put E11 into that VRF so that they both can communicate with each other inside of that VRF. So we're going to go ahead and knock that out real quick. The process is actually pretty straightforward. So I'm going to go ahead and get out of the way, and then we're going to say VRF, and we're going to say context is going to be vPC keep alive. Exit out of there, and we're going to go to interface eth1/1. We're going to do a quick show interface status. That's currently down. We're going to say it is. I want it to be routed. I need it to be an interface. I have an IP address on it. So I'm going to type in VRF member is going to be vPC keep alive. I'm going to say no shut, and I'm going to give it the IP address of 10.1.2. Actually, let's do 50.51.50/24. So show IP interface brief for VRF vPC keep alive. There it is, 50.51.50. I'm going to go ahead and save that config for right now. And then on 51, I'm going to do the same thing here. So VRF context is vPC keep alive. We're going to go to interface eth1/1. VRF member is going to be vPC keep alive. Now I had to put the interface into the VRF first before I can apply an IP address, because if I apply the IP address before I put it into the VRF, what will end up happening is by moving the interface from one VRF to the other, it'll remove its IP address. So just keep that in the back of your mind. 10.50.51.51/24, no shut. All right, so now what I get to go do is say vPC domain, and I'm just going to use, you can use whatever you want. I'm just going to say 55. So it says that vPC peer switch configuration is disabled. Please make sure to change spanning tree bridge priority as per recommended guidelines. That just means that the bridge assurance capability needs to be put into play so we don't run into loops. So I'm going to type in the vPC keep alive, or peer keep alive, the peer keep alive destination is going to be 10.50.51.51 inside of VRF vPC keep alive. It says management IP address. Management IP cannot be used as source. Oh, that's right, I forgot. Source is going to be 10.50.51.50. So we're good to go there. So now that we have that going, I'm going to go over to 51, do the exact same thing. I'm going to type in vPC domain of 55. I'm going to say the peer keep alive is going to be destination 50.51.50 VRF vPC keep alive. Source is going to be 10.50.51.51. So now that's in place. I'm going to go back over here to 50. I'm going to do a show vPC. It says peer is alive, which means the ping is working back and forth between the switches. So then I'm going to go ahead and go interface eth1/2 through 3. I'm going to go ahead and type in channel, or I'm sorry, it's going to be switch port mode of trunk. You don't need to worry about switch port, so we're going to say switch port. You don't need to worry about switch port trunk encapsulation .1q on here because ISL is not supported on Nexus. We're going to say switch port mode of trunk. And then we're going to say the channel group 100 mode active. And then interface port channel 100, vPC pure link. I'm going to go over to 51 now and do the exact same thing. So I'm going to type in interface range or interface eth 1/2 through 3. We're going to say switch port because right now all the ports are routed. Switch port mode of trunk. We're going to say channel group 100 mode active. And the interface port channel 100 vPC pure link. Okay, so we're going to go ahead and say show vPC as this pure link is down. So show interface status. I wonder if the interfaces, they're down. So we're going to go interface port channel 100. We're going to say no shut. And do the same thing at 50. So interface port channel 100, no shut. We'll say show interface status. I'm going to have to go to the interfaces themselves. So interface eth 1/2 through 3. No shut. There we go. Interface eth 1/2 through 3. No shut. So we'll go back over to 50. We're going to do a show vPC. It says pure link is down. That's okay though. So we're just waiting for it to finish its config. Show port channel summary. Okay, that's good. Show interface status. They're up. Show port channel summary. Show VPC. Peer adjacency formed okay. Good. So we're in good shape. Everything's working the way we expect it to. So now that that's in place, we're gonna do a show VPC. Everybody's happy. So the VPC is online. It's working the way we want it to. The next stage for us to do would be to, and so there's a question, why did I use port channel 100 instead of port channel 1 or something else? Well, the simple answer is this. When I configure VPCs, or whenever I have to configure VPCs, I should say, what I normally will do is I try to map it to the port number so that it's easy to identify what port it is. That's my logic in my brain. So I use port channel 100 for the VPC config because I know we're never going to get a port 100 on a switch unless we have like one of those bigger multi-stack or multi-U Nexus switches. So the likelihood of me getting a port 100 is pretty unlikely. So unless we're dealing with like a really high-end, high-throughput spine switch that's got multi 100 gig interfaces, but most of the case that's not the case. So I choose port channel 100 for my infrastructure link, and then for my downstream interfaces, I always go with, I'll use like VPC 4 will be my connection. So my port channel 4 will be port channel 4. We'll tie to VPC 4, so on and so forth. So I'm going to go on 50. I'm going to type an interface Ethernet 1/4. I'm going to say switch port mode of trunk. I'm going to say channel group 4 mode active. And the interface port channel 4, say VPC 4. Now I'm going to go over to 51 and do the exact same thing. So interface eth 1/4, switch port mode of trunk. We're going to say channel group 4 mode active. And then interface port channel 4, VPC 4. So if I show VPC, we're going to see that its consistency is configuration, or consistency is success. but the downstream switch is not configured. So let me bring switch 12 all the way over here. We're going to go to global config. Hostname is going to be switch 12. Then interface range, gig 0/0 through 1. We're going to say switch port trunk encapsulation .1q, switch port mode of trunk. And then I'm going to say the channel protocol is LACP, and the channel group is going to be so let's do 12 mode active. And we're going to give that a moment to do its thing. So if I go back over here to 50 and I hit the up arrow and do a show vPC, once it is able to talk back and forth, show interface status. Did I forget to turn enable? Yes, I did. So no shut. So interface eth 1/4 no shut. Interface eth 1/4 no shut. And then if I do a show vPC, once the interface comes online, show interface status. And then again, do another show vPC, it's up. So now I have an active vPC down to switch 12. We'll do the same thing here on 50. Show vPC. Perfect, it's up. Now we have to go create VLAN 20. So what I'm going to do is on here, I'm going to say, one of the things you have to do is a show vPC consistency parameters and then VLANs. One thing you're going to want to do is make sure whatever VLANs you've got created on one switch match what's configured on the other. So in this case here, I'm going to type in VLAN 20. Name is going to be PCs. So if I do a consistency parameter VLANs, it should allow everything to go across. If we do a show interface trunk, once VLAN, so we're not quite there yet. We need to allow 20 to do its thing, even though rapid spanning tree is enabled. 20 needs to be allowed. So if I go to 51 and I do a show vPC consistency parameters for VLANs, we are sort of out of we do global. We're going to have, it detects 20 on the other side. So if I go to 50 and I hit the up arrow, we should see 20s allowed on, but still not coming across. I might have to see what the deal is with that. It should be allowed to go across port channel 4. Okay, that's a little weird. But if I do a show vPC consistency parameters global, right, it detects local suspended VLAN as 20 because it doesn't detect it on the other side. So if I show run VLAN, right, it sees it. I have to go on to 51 and I have to go, actually let me just grab this config right here real quick. Go to 51, we'll configure that, exit out, and then now 20 should be allowed. And if we go back to 50 and hit the up arrow a couple times, 20 is allowed on 100. And port channel 4 should pick it up as well here momentarily. So we're just waiting for that to trigger. Show interface trunk. So what I'm going to go do is on switch 12, I'm going to go create, so we're seeing here it says it's not a full duplex. So interface range gig 0/0 through 1. I'm simply going to come in here and say switch port no negotiate. And then it's going to be speed, or sorry, is duplex is full. No switch port no negotiate. No. We should be good to go there. So do show interface trunk. And then we're going to go say VLAN 20 name PCs. And then do show interface trunk. Give that some time. Let's go back to 50. There it goes. Now 20 is available on port channel 4. Same thing here. Now it's allowed. 12 should have it as well. It might just take some time for this one here. This is what I'm waiting for, is 20 to be allowed across the port channel. And then once it is, we know we'll be in good shape, and that'll wrap up the video. And then we'll be able to move on into the routing components. There it goes. So we're good to go there. Show vPC consistency parameters global. Everybody looks good. I'm going to say term width is going to be 150. That doesn't really help. Okay, so everything looks good. In that respect, I'm going to go ahead and save the configs on everything. So last but certainly not least, when we get to, now that we've got this all stood up, what we'll be able to do is move out of switch campus, and we'll be able to start going back to routed infrastructure, and we'll start dealing with, okay, how do we get EIGRP to get everything running? And then we'll get everything, all this operational. We'll walk through, how to optimize certain things and stuff like that, and get into the weeds of how that type of stuff works. So if you guys have any questions, comments, concerns, feedback, drop that sucker in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.